Hello everyone, and we're now in example 9-9 from your textbook. And this is the first one of our examples to introduce shear stress. Now, shear stress is that cutting stress, the stress that is parallel to the force that's causing it. But when you think shear, think cutting, because when we're trying to calculate the area that we're going to use in our calculations, it's always the area that gets cut. It's the area that you see after cutting through it. Okay, so in example 9-9, we have a lap bolt, or sorry, a lap joint, which looks something like this. It's got two plates, and it has two bolts going through those plates with a nut on either side. Okay, and we're wondering what is the average shear stress in the bolts, because that's what's going to get cut. The plates aren't going to get cut. The shear stress, the bolts are. So now what does it give us? Well, it gives us that the bolts have a diameter of 0.75 inches, 3/4 of an inch, and that the load is equal to 18,000 pounds. These are some thick bolts, so maybe we can take it. Now, when this gets cut, if I were to suddenly pull super hard, what I would see is that my bolts break. Half of them goes one way, and half goes the other way. And if I was to then look at them from the top or from the bottom, what I would see is this. I would see some plate, and I would see two circles where they have been cut. And those circles would have a diameter of 0.75 inches. And I've got a force that's going that direction of P. So the area of these two circles is the area I need to calculate to solve my problem. So, area of a circle, we can look that up in the front of our book, is equal to pi over 4d squared, which is equal to pi over 4 times 0.75 squared. However, there are two of them, so we multiply it by 2 to get that second one in there. And that comes out to have an area of 0.884. Inches squared. Okay. Now I made a little small mistake here, but we're going to go with it just to show you what might happen to you. Now, what is the stress? What is the load that each bolt feels? Well, stress is equal to load over area. And we said that our area was 0.884 inches squared. But that's the area for both bolts. And each bolt felt the load, the load of 18,000 pounds. However, when there's both bolts together, they shared that load. So each of them individually would have felt 9,000 pounds, but together they feel 18,000 pounds. So as we've done it, since I did the area of both bolts felt the total force of 18,000 pounds. 18,000 pounds over 0.884 inches squared, which comes out to be 20,400 psi. Now, I could have also done it where I'm looking at only one of the bolts, just one of the bolts. If I had done that, I need to realize that since I'm only looking at one of the bolts, I'm only looking at half the force, because half of the force was felt by the other bolt. So instead, what I would have is my stress is equal to P over 2 over the area of one bolt. So that would be equal to 9,000 pounds over 0.441 inches squared, which is the area of one bolt, which comes out to be 20,400 psi. So it doesn't matter how you slice it, it comes out the same as long as you're careful. So when I do the area of both bolts, I feel the full load. When I'm doing the area of one bolt, I feel only half the load. Okay, I hope that makes sense. If you have any questions, please feel free to email, and I will see you next time.